How's it going, guys? Let's start our UIL adventure with number-based conversions. This will always be the first question on the UIL exam. Okay, it will be some kind of conversion. I want to start with some simple things. I want to start with converting any of the bases to base 10. And let's see what I mean by any of the bases. We're going to have four bases. Our first base is base 10, which is, oh goodness, base 10, which is what we normally use. Base 2, which is binary. Base 8, which is octal. And base 16, which is hexadecimal. These are the four bases we have to worry about, okay? Let's look at what we mean by the term base. If I have a number, let's say 125, okay? What this is place value. So this place value is the ones, the tens, and the hundreds. Here's how we would write that. We would say base 10 to the 0, base 10 to the 1, and base 10 to the 2. So let's dig a little deeper into that. What we have is a base and an exponent. So the exponent of 0, exponent of 1, exponent of 2, and this is called our base. I mean, that's just math. Okay, so that's where the term base comes from. 10 to the 0 is a 1. Any number raised to the 0 power is a 1. So we're going to call this our ones place. 10 to the 1 is a 10. We're going to call this our tens place. 10 to the 2 is 100. So we're going to call that our hundreds place. Okay, so how we say this is we have 1 100, 2 tens, and 5 ones. Okay, what I want to show you is how that connects with the other bases, this same method of place value. Okay, so I'm going to erase this, and we're going to look at a binary number the exact same way. Let's look at 1 1 0 1. If you saw this on a exam, it would look like this: 1101 base 2. Okay, that's how they would write it to indicate that it's a base 2. This is not 1101. This is 1101 base 2. Okay, we set this up the exact same way. This first place value, this is base 2, so it's going to be 2 to the 0, 2 to the 1, 2 to the 2, and 2 to the 3. 2 to the 0 power is 1, 2 to the 1 is 2, 2 to the 2 is 4, and 2 to the 3rd is an 8. So the exact same thing we just did. This is the 8th place, the 4th place, 2's place, and the 1's place. I'm going to show you how we convert this to tens, to a base 10 decimal. What we say is we have 1 8. I'm going to write that over here. We have 1 4. We have no 2's, but we have 1 1. 8 plus 4 is 12, plus 1 is 13. That is 13 base 10. Okay? What we just did is we converted 1101 base 2 binary to base 10 very easily. Okay? Once you learn these, and binary is pretty simple, you'll learn what the place values are without having to write these numbers. It'd be 1, 2, 4, 8, 16, 32, 64, 128, so on. Okay. And we'll look at some of those later. But I want to keep it kind of simple. What I want to draw now is a correlation between this method and how we can use it with any of these bases to convert to base 10. So let's come up with a base 8 number. Let's use kind of a bigger one. let's do 263. Okay. Now this is going to be base 8. So here's how this would be written. Okay. This is 8 to the 0, 8 to the 1, 8 to the 2. Any number raised to the 0 power is a 1. So this is our ones place. And 8 to the 1 is 8. So that's our eights place. 8 to the 2. This is 64. So that's our 64's place. I know that sounds crazy, right? So here's how we would convert this to tens. This is saying we have two 64s. 64 times 2 is 128. So I'm going to go ahead. I don't need to do that math. I can do that in my head. I'm pretty smart. So I'm going to go ahead and write that over there, just like I did up here. This is saying I have 6 eighths. Well, what's 6 times 8? 6, 12, 24, 48. Okay. So I have 48 there. This is saying I have 3 ones to tack on to the end. What I just did was I just converted all of these to ones. I have 128 ones here. I have 48 ones total here. 3 ones total here. Then I'm going to add them up. 8 and 8, 16. 16 plus 3, 19. 4 plus 2 plus 1, 7. And a 1. Base 10. I just converted 263 base 8 to base 10, 179. I'm going to show you one more, how to go from base 16 to base 10 the exact same way. But in order to do that, I need to show you quickly a chart, because base 16 gets a little crazy. If you've seen base 16 before, this is not that crazy if you've seen it and you kind of understand it. But if you've never seen it, it won't make sense. So I want to show you a chart. With my APCSP students, we don't have to do Octal. And so I teach them to create this chart. And I'm going to start up here because I did this earlier and I ran out of room. Okay. We're going to start with decimal. I'm getting used to this tablet. And so this is going to be a really cruddy looking chart. I can't draw a straight line with this thing. Okay. Binary and hex. So instead of teaching my APCSP kids how to do that other method, because some of them get confused, I just teach them to brain dump a chart. Here's what this chart looks like. We're going to go from 0 to 15 with decimal. Let's see here. Try to make this as clean as possible. Just got this writing tablet, so I'm getting used to it. Okay. Now we're going to go from decimal to binary, and it's going to become clear why I went to 15 here in a second. I'm going to put back up my binary place value here real quick. Remember, this was our ones, this was our twos, our fours, and our eights place. Okay, and there's a reason I want to do that, because I want you to draw a correlation between what I'm about to do and these place values. Okay, so 0 in decimal is 0, 0, 0, 0 in binary. We have nothing. We have no eights, no fours, no twos, no ones. All zeros. The 1 in binary is 0, 0, 0, 1. We have 1, 1. Okay. 2 is going to be 0, 0, 1, 0, meaning I have 1, 2. 3, 0, 0, 1, 1. I have 1, 2, and 1, 1. 4 is I have 1, 4 right here. So let me do that. That would be 0, 1, like that. I have 1, 4. Okay. A 5, a 4, and a 1. A 6, a 4, and a 2. 7, a 4, 5, 6, 7. An 8 is just 1 8. A 9 is an 8 with a 1 on it. A 10 is an 8 and a 2. And I've done this quite a bit. That's why I'm going a little fast. An 11 would be that same one we just did with a 1 attached. 12 is an 8 and a 4. 13 is that same number with a 1 attached to the end. 14, an 8, 12, and a 2. Okay, 15 is going to be all ones, all turned on. So you can kind of see why I went to 15 already. I went all the way from all zeros to all ones. Okay, hex is a little different. So with base 10 decimal, I have 10 digits that I work with, 0 through 9. And then I start over. I go to 10 and I go from 10 to 19. Then I start over. I go to 20 to 29. And then I go to 30. So I have 9 base digits or 10 base digits. With binary, I have 2, 0 and 1. With hex, I have 16, but they get a little crazy. Let me show you what they are. From 0 through 9 is going to look the exact same as decimal. So from there, it's pretty simple. So a 9 in decimal is a 9 in hex. A 5 in decimal is a 5 in hex. Pretty easy. Once I get past 9, though, I start with letters. I know, crazy, right? E and F. Now, if you've done any web design with me before or been in CSP, you've probably seen these letters before because we deal with colors a lot with hexadecimal in web design, and you'll see letters thrown in to those colors. Don't want to get into that right now, but just want to make that connection. Here's why I wanted to do this chart. So my CSP kids, they just brain dump this chart, and they can use it to easily convert between one and the other. That doesn't help us a lot. I mean, if you like the chart, use it, but it doesn't include base 8. And that's kind of the kicker. But I needed to show it to you because I want to do a conversion with hex, like we did the others. And I'm going to do kind of a difficult one to start with because I just feel like, that'd be good to do. So let's say that I had A, F, base 16. Okay. This is, recall, this is I'm going to use the exact same method I used a second ago to convert AF base 16 to base 10. This is base 16, so I'm going to do this. I have a base of 16. All right. This one, okay, this is my ones place. Like always, this is my 16s place. All right. Now I'm not going to lie. This one is a little more difficult to wrap your head around than the others I just did because of the A's and the F's and the letters, right? So what I got to do, I have to know that F is a 15 in hex. Okay. Whether you memorize the whole chart and you brain dump it, which is, I'll be honest, it's what I do. I did it on my CS exam. I do it when I do UIL exams. I'll brain dump this whole chart. But you don't have to. All you really have to learn is the hex digits, 0 through 9 and A through F. The reason is you have to know that F is a 15. So I really don't know a great way to do this. I'm just going to denote it here that this is a 15. This A is a 10. So I'm just going to denote that here. Okay. What this is saying is that I have 10 16s. Okay. This is the exact same way I did it a second ago. 16 times 10, we're just going to say it's 160. Okay. So when I come over here to do my addition, I've got 160 ones right here, 10 times 16. This F is a 15. This is my ones place. So I have 15 ones to add to the end. AF base 16, 175 base 10. Okay. We use what I want you to make a connection with is that we use the exact same method to convert any of these to base 10. The exact same method. Are there other methods out there? Yes, there is. Of course, there is. This is the one that ONCS uses. This is a very simple method that I would use, right? Base 16 is just a little more difficult, like I said, because you have to understand that there are, it goes 0 through 9, and then it picks up some letters, okay? Because you have to know that A is 10 and F is 15. That's the only crazy thing really about any of this and about base 16. Okay. Next, we're going to take a look at the method we use to convert the other direction. Okay, so going from one to the other. All right, so stay tuned for that.